Good morning, everyone. Today we are going to learn about the remaining interview questions of VLSI DFT. My first question is, what problems you faced while inserting a test point? So we don't face any problems, but the thing is that we should keep it in mind that selecting a best location for the test point insertion and area overhead are the two major problems we are facing the test point insertion. Next question is, what is the difference between the clock skew, local skew, global skew, and useful skew? Not clock skew, local skew, global skew, and useful skew. Local skew, skew between the register to register path, one register to another register path. And global skew is a skew between all the registers in the clock domain. Suppose we have a clock domain. So in the clock domain, all the register skew is the global skew. And useful skew to advance the clock in register to register path in order to meet the setup time. So the useful skew, that is a positive skew, is good for setup. What is atpg effectiveness? So atpg effectiveness is defined as the percentage of atpg resolvable faults out of the total faults. Out of the total faults, how many faults are resolved by the atpg is called the atpg effectiveness. Next question is, why we lose coverage when we constrain the pin? It's very simple. When we constrain the pin to either 0 or 1, so we can't able to toggle it. That is the thing. So that's why we will lose the coverage. So in general, whenever you constrain any pin of the device, you can take away the ability of the ATPC to toggle that pin and check it in the both the states. Sometimes when you constrain a pin, it will have a negligible effect. Sometimes it will have far ranging effect on the fault coverage because that pin is driving the large cone of logic. So if you constrain that particular pin, we can't able to cover the faults in that cone of logic. That is the thing. My next question is, why at speed pattern count is more than the stuck at pattern count? The question is, why at speed pattern count is more than the stuck at pattern count? For a full scan design, stuck-at atpg looks at generating the patterns in a combinational logic block in between the scan blocks. This is because every scan block can be treated as a primary input and a primary output for stuck-at atpg purpose. However, when testing for at-speed failures, patterns are generated to launch a transition and capture the effect into a scan block. Therefore, ATPG needs to trace back beyond one level of the scan block to figure it out how to get the appropriate second pattern in a second pattern test, which means it has less degree of freedom in how to assign a scan flip-flops to detect a fault, which leads to higher pattern count. Okay, this is all about today's lecture. We will continue the remaining questions in the next lecture.